This is a question of IIT JEE. The solution to this question given in the book of Disha publication etc. was very lengthy. Therefore, I thought that I should make a video solution of this question also. Otherwise, it is not difficult, but still because they had done in a very lengthy way, hence I am making the video solution of this. Otherwise, there is nothing much difficult in it. In this question, it is given that let L1 be a straight line passing through origin and L2 be the straight line x plus y equal to 1 if the intercept made by the circle x square plus y square minus x plus 3y equal 0 on L1 and L2 are equal, then which of the following equations can represent L1? You can check yourself that in the book of Disha publication the solution was too much lengthy. First of all, this is a circle whose equation is x square plus y square minus x plus 3y equal to 0, and x plus y equal to 1 is a line making some intercept on this circle, and the name of this line is L2, and L1 is a line which is passing through origin. Origin lies on this circle, therefore I can take this as origin, and you have to find the equation of L1 so that the intercept made by this line and this line on the circle are equal. Clearly the center of this circle is 1 by 2 comma minus 3 by 2. Actually it is not required to find the length of intercept and equate the length of intercept. No, it is not good, and it is not difficult to see that the length of intercept will be equal if the distance from center are equal. Means I find the value of m for this line so that the distance CA and CB are equal. Clearly CA equal to 1 by 2 minus 3 by 2 minus 1 mod upon under root 1 square plus 1 square, that is root 2. And if I have supposed the slope of this line as m, the equation of this line will become y equal to mx, that is mx minus y equal to 0. Now clearly CB will be equal to m by 2 plus 3 by 2 mod upon under root m square plus 1, and because CA and CB are equal, this is equal to root 2. That is, I get m plus 3 mod is equal to 2 root 2 under root m square plus 1, that is m square plus 9 plus 6m equal to 8m square plus 8. That is, I get 7m square minus 6m minus 1 equal to 0. That is clearly m equal to 1 and minus 1 by 7. How I have obtained these directly? Because m equal to 1 is clearly the root of this, and because product of the root is minus 1 by 7, if one root is 1, other root will be automatically minus 1 by 7. Hence one line becomes y equal to x, other line becomes y equal to minus 1 by 7x. That is, the lines are x minus y equal to 0 and x plus equal to 0. Hence I can say B and C both are correct choices. Actually, this question in the book of Disha publication was in the chapter of straight line, but actually it must have been in the chapter of circles. But still, the main thing is the solution given in the book was very lengthy. This was the proper way of doing this question. Actually, this was a solution to this question in the book of Disha publication. You can see how much lengthy it is. This is the question of IIT 1997. It's a beautiful question, but because the solution given in the book of Disha publication and many more places also, I found them as wrong. For example, this is the solution given in the book of Disha publication, and this solution is absolutely wrong solution. And from solution it seems that it is a very difficult question, but actually this question can be done in 3 lines with very simple calculation. Actually the present question can be done just in 2 lines, but for complete clarity of this question I will do this question in 3 parts. First part, when both the coordinates of center are rational number. Second part, when one coordinate is rational and other coordinate is irrational. And third part, when both the coordinates are irrational. But note that I am dealing with the case of when both the coordinates of irrational number, but the two irrational number should be of different type. If they are of same type of irrational number, then the question will reduce to the type of the question in which one coordinate is rational and other coordinate is irrational. Different type of irrational number and same type of irrational number means, for example, root 2 and 3 root 2 minus 4. They are same type of irrational number, because this can be converted to this by doing some rational operation on it. Rational operation on it means by multiplying, dividing, adding or subtracting by a rational number. If I can get this, then I will say they are same type of irrational number. But root 2 and root 3, they are different type of irrational number. If this type of irrational number are coordinates of center of the circle, in that case at the most one rational point is possible on the circle. If this type of irrational number are there at the center of circle, or one coordinate rational and other coordinate irrational, in that case at the most two rational points are possible on the circle. And if both the coordinates are rational, in that case any number of rational points are possible on the boundary of circle. I'll be explaining each case one by one. Actually I am dealing all the cases just for crystal clarity of solution of this question. First I will prove that if three rational points are there on the boundary of circle, in that case the center will have to be a rational point. Rational point means whose x coordinate, y coordinate both are rational number. See why. Suppose this is a circle having x1 y1, x2 y2 and x3 y3 on the boundary of circle. And suppose you have to find the equation of circle. The procedure which we are always using is, let the equation of circle be x square plus y square plus 2gx plus 2fy plus c equal 0. This procedure you must have studied in 11th class, that if this is the equation of circle, by putting x1 y1 in this, you will get one linear relation between G, F and C, and that linear relation will not be containing any irrational number because I have supposed x1 a1 as both rational number. Similarly, when I will put x2 y2 in this, I will get another linear relation in G, F and C, which will be again containing only rational numbers. Similarly for x3 y3, and by putting these three coordinates in this, I'll be getting three linear relations between G, F and C. And because those linear relations are not containing any irrational number, it is obvious that we can see very easily that the values of G, F and C I'll be getting will be all rational numbers. Hence, if three rational points are possible on the boundary of circle, then center will be surely a rational point. Rational point means whose x coordinate, y coordinate both are rational number. Hence, we can easily say that if the center is 0 comma root 2, then three rational points is not possible on the boundary of circle. But in this case, two rational points are possible. How can I say this thing? See, before I do this, let me explain you this concept. Otherwise, you must have studied this concept in lower classes also. If a plus b root 2 is equal to c plus d root 2, where a, b, c, d are all rational numbers, this surely means that a will be c and b will be d. Obviously, if a plus b is equal to c plus d, doesn't mean that a equal to c, b equal to d is surely there. Surety of this doesn't come from here, but surety of this comes from here. Note that I am taking the case when a, b, c, d are all rational numbers. And now I am going to prove that if the coordinate of center are 0 comma root 2, then two rational points are possible on the boundary of circle. Obviously, if the center is 0 comma root 2, the equation of circle will be of the form x square plus y square minus 2 root 2 y plus c equal to 0. If x1 y1 and x2 y2 are 2 points on the boundary of circle, and now I will tell you the situation in which two rational points are possible on the boundary of circle. To understand that situation, if x1 a1 lies on it, x1 square plus y1 square minus 2 root 2 y1 plus c will be 0. If x2 y2 lies on it, then x2 square plus y2 square minus 2 root 2 y2 plus c will be 0. And now I subtract the two equations. I get x1 square plus y1 square minus x2 square minus y2 square minus 2 root 2 into equal to 0. Right hand side 0 means I can say 0 plus 0 root 2. It surely means that x1 square plus y1 square minus x2 square minus y2 square is 0 and y1 minus y2 is 0. Note that I am saying it surely means. This means x1 square equal to x2 square and y1 equal to y2. That is, I can say x1 equal to plus minus x2 and y1 equal to y2. That is, I have got the conclusion that If x1 y1 and x2 y2, two rational points are there on the boundary of that circle, then it is sure that x1 and x2 will be just negative of each other and y coordinates will be surely same. For more clarity, geometrically we can easily see that if I take the center as 0, root 2 and draw a circle passing through 1, 0, then it will surely pass through minus 1, 0 also. Otherwise, we can say this thing also. If the center is 0, root 2 and it is passing through the point 3, minus 4, then it will surely pass through minus 3, minus 4 also. You can see very easily y coordinates are same and x coordinates are negative of each other. And more than two rational points are not possible because I just now explained that if three rational points are there on the boundary of circle, then the center will have to be a rational point. That is, the coordinate of center of the circle will both have to be a rational number. And now the third case, if the coordinate of center are both irrational number of different type. What is the meaning of different type of irrational number that I have explained in the very beginning? Suppose the coordinate of center are root 2, root 3. Clearly these are different type of irrational number. I will prove that the circle whose center is root 2, root 3, on the boundary of that circle at the most one rational point is possible. Even two rational points are also not possible on the boundary of this circle. See why. If I say, suppose x1 y1 and x2 y2 are two rational points are there on the boundary of circle with center root 2, root 3. If I reach at contradiction, it means two rational points is not possible. Some of you may think that even one rational point is possible or not. Obviously, one rational point is surely possible because we can easily draw a circle with center root 2, root 3 and passing to the point say 2, 3. Whatever is this distance, take this distance as radius and these coordinates as center. The equation of circle you will be getting to that circle 2, 3 will satisfy this and any other rational point cannot satisfy this. This I am going to prove. It is clear that the circle with center root 2, root 3 will have the equation of the form x square plus y square minus 2 root 2x minus 2 root 3y plus c equal to 0. If x1 y1 x2 y2 both are, if both these rational points are lying on this circle, it will mean that x1 square plus y1 square minus 2 root 2 x1 minus 2 root 3 y1 plus c equal to 0, and if x2 y2 also lies on it, then x2 square plus y2 square minus 2 root 2 x2 minus 2 root 3 y2 plus c will be 0. And now I subtract the two equations. I get x1 square plus y1 square minus x2 square minus y2 square minus 2 root 2 into x minus x2 minus 2 root 3 into And as I told in the very beginning that if a plus b root 2 plus c root 3 is equal to e plus f root 2 plus g root 3, it surely means that, note that I am saying surely mean that a will be e, b will be f, and c will be g. Hence, using this argument, I can surely say that x1 minus x2 is 0, y1 minus y2 is also 0, and if I take these two as 0, obviously this will become 0. That is x1 equal to x2 and y1 equal to y2. That is x1 y1 and x2 y2 are same points. Hence, two different rational points are not possible on the boundary of circle with center root 2 comma root 3. This is a question of JEE Advanced 2016. I am making this video because I found that the solution given everywhere was difficult, lengthy and calculative, but I will be telling you the solution which is simple, short and very less calculative also. In this question it is given that let RS be the diameter of circle xk plus y square equal to 1 where S is the point 1 0. Let P be a variable point other than R and S on the circle, and tangents drawn to the circle at S and P meet at the point Q. The normal to the circle at P intersect the line drawn through Q parallel to RS at the point E. Then the locus of the point E passes to the points. You have to find the correct choice. The meaning of question is, you are given a circle whose equation is x square plus y square equal to 1, and this is a point S having coordinate 1 0, and RS being diameter, obviously R will be here. Let P be a variable point on the boundary of circle different from R and S as given in the question. And now it is given that tangent to the circle at P and S meet at the point Q. And now he says the normal at P, obviously normal will surely pass to center also, intersect the line passing through Q parallel to RS at the point E, and you have to find the possible coordinate of the point E, that is E can be which of these is correct choice. If you have studied the question carefully, it is obvious that if 1 by 3 comma 1 by root 3 will satisfy the locus of E, then obviously 1 by 3 comma minus 1 by root 3 will also satisfy the locus of E, because had I taken P point just below as a mirror image of this point, the coordinates of E will be having only difference in y coordinate. X coordinate of this and this will be same. That is, I can say if A is correct choice, then C is surely correct. If B is correct, or then D is also correct. Then so far we have got the conclusion that either A and C both are correct, or B and D both are correct, or A, B, C, D all are correct. Now see how to proceed. Let the point E be HK. I will check H equal to 1 by 3 and K equal to 1 by root 3 is possible or not. I will try to find the relation between H and K. It is obvious that because this is HK, this will be having coordinate 1 comma k, because x coordinate of q will be same as x coordinate of s, and y coordinate of this point will be same as y coordinate of q. And how I will find the relation is, I will find the coordinate of p and use the fact that PQ is perpendicular to OP. And one more thing, you will note that I'll be able to judge the correct choice without even doing the complete calculation. What I mean to say, you will understand at the end of this solution. As the radius of this is 1, it is not difficult to see that the coordinate of P will be automatically h upon under root h square plus k square and k upon under root h square plus k square. Actually, if you have prepared for JEE Advanced, it should not be required for you to find the coordinate of P. Just by looking at the question, you should be able to say that if E is HK, then P will be this, keeping the concept in mind that radius of this is 1. Still, if you have not understood, then I am going to explain also why the coordinate of P are this if E is this. Say this angle is theta, then this length will be K and this length will be H. Suppose this point is A. Then tan theta will be K by H. Obviously, this point is cos theta sin theta, and because tan theta is K by H, cos theta will be this and sin theta will be this. And now, to find the relation between H and K, we'll be using the fact that OP is perpendicular to PQ, and hence we'll be using this formula that because product of slope of perpendicular lines is -1, hence slope of OP into slope of QP will be -1. Slope of OP is obviously K by H into slope of QP, that is K minus K by under root H square plus K square upon 1 minus H upon under root equal to -1. That is, I have got the conclusion that K square into under root H square plus K square -1 is equal to H into H minus under root H square plus K square. This implies that K square plus H under root is equal to that is get under root further note that it is not required to square both sides and calculate. Just see, because we have to see only correct choice. Obviously note that because for any of these points, right hand side is surely a rational number because K square is there. Otherwise you can put the values and check also, but just to save few seconds also, I can easily say that right hand side is sure to be a rational number. Therefore, h and k can be having only those values for which this is a rational number. Under root h square plus k square. Clearly, for this case, this is a rational number. Obviously, this also makes it rational, but this doesn't make it rational. Agreed? We can check by properly calculating both sides also, but that is not required because one of the choice is surely correct. If you see h equal 1 by 3 and k equal to 1 by root 3, you will be getting 1 by 9 plus 1 by 3, that is you will be getting 4 by 9, that is 2 by 3. But if I use 1 by 4, 1 by 2, you will be getting 1 by 16 plus 1 by 4, you will be getting under root 5 by 16, that is root 5 by 4. And without even calculating further, we can easily say that this cannot be satisfied. Hence, obviously, A and C are correct choice.